Welcome back to Max with RP. Today we are going to solve simple problems in three-dimensional geometry based on the topic of straight lines. Let's look at the problems. How to find the vector equation of a line which passes through 2 points. So for any line equation there are two forms. One is the Cartesian form, the other is a vector form. So what is the Cartesian form? We will write both the forms. Cartesian form of a line is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. Okay, now x1, y1, z1 is a fixed point that the line passes through, and x2, y2, z2 also is another known point that the line passes through. X, y, z represents the variable point. Now substituting for x1, y1, z1 as 3, 4, minus 7 and x2, y2, z2 as this. So this is x2, y2, z2. This is x1, y1, z1. So what will you get? X minus 3 by x2 minus x1. So 1 minus 3, which is minus 2, equal to y minus 4 by y2 minus y1. Minus 1 minus 4, which is minus 5, equal to z minus of minus 7, which is plus 7, by z2 minus z1. 6 minus of minus 7, which is 13. So this is the Cartesian form. So x minus x1, which is x minus 3 by x2 minus x1, which is 1 minus 3, which is minus 2, equal to y minus 4 by minus 1 minus 4, which is minus 5, equal to z minus of minus 7, which is z plus 7, divided by 6 minus of minus 7, which is 13. Okay. Now we have to convert it into vector form. What is the vector form of the equation of a straight line? R vector equal to A vector plus lambda times B vector minus A vector. That is R vector equal to, what is A vector? Position vector of a point, which is this 3i. So it passes through this point, right? So 3i plus 4j minus 7k plus lambda times b vector minus a vector, that is 1 minus 3, which is nothing but the denominator. So minus 2i minus 5j plus 13k. So this is the Cartesian equation is this, and vector equation is R vector equal to A vector plus lambda times B vector minus A vector, where A vector and B vector represents the position vectors of 2 points on the line. Next question. So this is what we did. So we are looking at a different question. The equations of a line are given. You have to find the direction cosines of the line and the coordinates of a point through which it passes. So first of all, is it in the standard form? Pi x minus 3 equal to 15y plus 7 equal to 3 minus 10z. What is the standard form? X minus x1 by A equal to y minus y1 by B equal to z minus z1 by C, where x1, y1, z1 represents a fixed point on the line, or with the point whose coordinates we know through which the line passes, and ABC represents the drs of the line. Now that means here you observe the coefficient of x, y, z, the variables are all 1. So we have to redefine the same thing. So I am going to divide by 5. So I'll get x minus 3 by 5, okay, is equal to y plus, so how should I write it? Y plus 7 by 15. 15 if I take out. See here I've taken 5 outside. So what will I get? 5 into x minus 3 by 5. Here I will take 15 outside. What will I get? Y plus 7 by 15 equal to 3. If I take outside, I will get 1 minus 10 by 3 z. But how should it be? It should be z minus z1. So I'm going to rewrite this as x minus 3 by 5. If I bring this 5 to the denominator, it will become 1 by 5 because I want to bring it into that form. This will be y plus 7 by 5, 7 by 15 divided by this 15. If I bring it to the denominator, it will become 1 by 15 equal to, I'll first write 10z by 3. Actually, see, this is 10. I want to, this is the same thing. I can rewrite it as minus 3 into, right? See, this is, I can write it as minus 3. This is not in the standard form. So I'm going to write this I can write it as minus of 10z minus 3. This will be, I'll take out this minus 10 outside. Then what will I get? Minus 3 by 10. So within bracket I am dividing by 10. Okay. Into minus 1. Minus 10. So this will be minus 10 into z minus 3 by 10. The same thing I can rewrite this as z minus 3 by 10 by minus 1 by 10. So this is 5 into x minus 3 by 5 by 1 by 5 equal to y plus 7 by 15 by 1 by 15 equal to z minus 3 by 10 by minus 1 by 10. Now, what is the point through which the line passes? The line passes through 3 by 5 minus 7 by 15 comma 3 by 10. What are the drs of the line? Drs are 1 by 5, 1 by 15 minus 1 by 10. Okay, so which is same as, okay, if I write it in the form of a ratio, this is 1 by 5 is to 1 by 15 is to 1 by 10. Okay, if I multiply throughout by 15, what will I get? Or rather, I will reduce this by multiplying by 15 into 10. I will get what? See, I can, the LCM of 15 and 10 is what? 15 and 10. If I take LCM, I will get, so I will get 30. So take 30 as LCM, then I will get 6, 2, 3. So DRs are 6 is to 2 is to 3 will be the DRs. What will be the DCs? DCs are given by a by root of a square plus b square plus c square, b by root of b square plus c square plus b by root of a square plus b square plus c square, and c by root of a square plus b square plus c square. So direction cosines will be 6 by root of 6 square is 36 plus 2 square which is 4, 40 plus 9, 49 which is 7. So the direction cosines will be 6 by 7, 2 by 7 and 3 by 7. So this line passes through the point 3 by 5 minus 7 by 15, 3 by 10, and its DRs are 6 is to 2 is to 3, and the direction cosines are given by 6 by 7, 2 by 7 and 3 by 7. So is it clear? So we have done one sum. Next sum. The Cartesian equation of a line AB is this. Find the direction cosines of a line parallel to the line AB. First of all, again, when you look at the line AB, it is not in standard form. So, what is the step number 1? Bring it into the standard form. What is the standard form? X minus x1 by A equal to y minus y1 by B equal to z minus z1 by C. So, this one I can write it as x minus 2 into x minus half by 12 equal to y plus 2 by 2 equal to z minus 3 by 3. This is further x minus half by 6 equal to y plus 2 by 2 equal to z minus 3 by 3. So, what are the DRs of this line? DRs are 6, 2 and 3. What will be the direction cosines? Direction cosines are a by root of a square plus b square plus c square, b by root of a square plus b square plus c square, c by root of a square plus b square plus c square. So, you will get 6 by root of 6 square 36 plus 4, 40, 40 plus 3 square, which is root 49. That is 6 by 7, 2 by 7 and 3 by 7. So, the DCs are 6 by 7, 2 by 7 and 3 by 7. If they ask you what is the point on the line, the point that we know is half minus 2, 3. Point on the line is half minus 2, 3. So, I hope you understand now how to write the equation of a line in Cartesian form, recognize a given line in Cartesian form, how to convert it into vector form, how to write down the coordinates of a point on a given line when the equation of a line is given, how to write the DRs and how to write the DCs. Next problem. The x-coordinate of a point on the line joining the two given points P and Q is 4. Find its z-coordinate. So, what is first of all, let us write what is PQ. Equation of PQ. How do you write equation of PQ? X minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. So, it is x minus 2. This is your x1, y1 is z1 and this is your x2, y2, z2. So, you get x minus 2 by 5 minus 2 which is 3 equal to y minus 2 by 1 minus 2 which is minus 1 equal to z minus 1 by minus 2 minus 1 which is minus 3. Just check, 5 minus 2 is 3, 1 minus 2 is minus 1, minus 2 minus 1 is minus 3. x1, y1, z1 is 2, 2, 1. Okay. Now, what is it given? The x-coordinate of a point on the line joining the points is 4. So, if this x-coordinate is 4, we want to find what is the z-coordinate. Let the x-coordinate of the point on the line be 4. If the x-coordinate is 4, that means that point satisfies the equation of the line. Then what will I get? Replacing x by 4, 2 by 3 is equal to, I want to find what? The z coordinate. So, I am going to equate z minus 1 by minus 3. So, minus 2 equal to z minus 1. Because dividing throughout by 3, this is equivalent to 2 by 1 equal to z minus 1 by minus 1. So z minus 1 is minus 2. So z equal to minus 2 plus 1, which is minus 1. So when the x coordinate of a point is 4, the z coordinate is minus 1. If I ask you to find the y coordinate, what will you do? It's not asked, but you can ask, right? So what will be the y coordinate? So y minus x coordinate, when the x coordinate is 4, right? I'll get 4 minus 2 by 2, which is 2 by 3, is also equal to y minus 2 by minus 1. Therefore, minus 2 equal to 3y minus 6. So 3y is equal to 4. Y equal to 4 by 3. See, this is 2 by 3 equal to y minus 2 by minus 1. So minus to cross multiplying will give you 3y minus 6. So 3y, I am keeping it as it is, plus 6 we bring it here, 6 minus 2 is 4. So y is equal to 4 by 3. So actually when the x coordinate is 4, the y coordinate is 4 by 3 and the z coordinate is minus 1. So are you able to understand how to get the coordinates of a point when you know the equation of a line and an additional information? In this case, the additional information is the x coordinate of a point is given. How to find angles between the lines? First of all, step 1 always should be followed. What is that step 1? Write the equations of the line in the standard form. This is x by half, so L1 is x by half equal to y by 1 by 3 equal to z by minus 1. What is L2? X by 1 by 6 equal to y by minus 1 equal to z by minus 1 by 4. What is the angle between two lines? Cos theta equal to A1 A2 plus B1 B2 plus C1 C2 by root of A1 square plus B1 square plus C1 square into root of A2 square plus B2 square plus C2 square. So, cos theta will be equal to, what is your A1, B1, C1? This is my A1, this is my B1, this is my C1. This is my A2, B2, C2. Okay, the DRs of the two given lines. What is A1, A2? Half into 1 by 6. Then plus B1, y plus 1 by 3 into minus 1. Then C1, C2, minus 1 into minus 1 by 4, which is plus 1 by 4 by root of 1 by 4 plus 1 by 9 plus 1 into root of 1 by 36 plus 1 plus 1 by 16. I am going to leave it to you to simplify this. This is 1 by, or rather if you want it, you can rather simplify this direction ratios like this. 1 by 2 is to 1 by 3 is to minus 1 is equivalent to, let us multiply throughout by 6. Then what will I get? 3, 2, minus 6. 3, I am multiplying by 6. So 3, this will become what? 6 by 3 is 2, minus 1 into 6 is 3, 2, minus 6. Because if I keep it like this, the calculations involves fractions. If I write like this, maybe it is simpler. Here what should I divide? How will I simplify? 1 by 6 minus 1 minus 1 by 4. Multiply throughout by, what is the LCM of 6 and 4? 24. Suppose I multiply by, see, 6 and 4. If you take the LCM, you know it is 12. So let me multiply throughout by 12. Then I will get 2. When I multiply this by 12 minus 12 minus 3. I am multiplying throughout by 12. So 12 by 6 is 2. 12 by minus 1 is minus 12. 12 minus 12 by 4 is minus 3. Why am I doing it? Now this is one set of drs. So for L, this is L2 drs. What is L1 drs? 3, 2, minus 6. So it could be probably the calculations can be much easier if you take it like this. So what will be the calculation? Let me first remove this. So cos theta equal to, so now you can take this as A1, B1, C1, A2, B2, C2. So 2 into 3, 6, minus 24, plus 18 by root of 4 plus 144 plus 9 into root of 9 plus 4 plus 36. In fact, this becomes redundant because 18 plus 6 is 24. 24 minus 24 is 0. So what is theta? 90 degrees. The two lines are perpendicular to each other. So you must know how to simplify the direction ratios and then find the angle, because it will make the calculations much simpler. Find the next problem. Find the vector equation of the line passing through a given point and perpendicular to two lines. See, when you have a line and it is perpendicular to two lines, say L1 and L2. If I take L1 cross L2, it will be parallel to the original line. See, this is L1 cross L2 is what? It will be what? It's a vector which is perpendicular to L1 and L2. So, naturally it is parallel to the given line which is L, whose equation we want to write. What is L1? It is given x minus 1 by 1 equal to y minus 2 by 3 equal to z minus 3 by 3. What is L2? L2 is x minus 3 by 3 equal to, sorry, x by minus 3 equal to y by 2 equal to z by 5. I want to find the equation of this line passing through the point 2, 1, 3. This line contains the point 2, 1, 3. And it is perpendicular to these two lines. But we know that the cross product of L1 and L2, I mean of the drs, that is I plus 2j plus 3k and minus 3i plus 2j plus 5k will also be parallel to L1 and L2. A cross B is perpendicular to A and B. So here L1 cross L2, when you take the cross product of the drs, it will be parallel to the original line, whose equation we want to write. The given line we know passes through 2, 1, 3. So, any line we need to know two things. X1 by A equal to y minus y1 by B equal to z minus z1 by C is the equation of the line in standard form. What is x1, y1, z1? Point on the line. So, x minus 2 by A equal to y minus 1 by B equal to z minus 3 by C. So, I have substituted for x1, y1, z1. Now, I need to find A, B, C. If it is perpendicular to both the lines, the product of the drs will be parallel to the given line, as we have seen. This line, which is perpendicular to L1 and L2, will be parallel to the original line. So, to find A, B, C, you have to just take the cross product. So, how will you take the cross product? Determinant I, J, K, 1, 2, 3, minus 3, 2, 5. This will be I into, leave out that column and row, 2 5s are 10, 10 minus 6, 4. Then minus j into, leave out that column and row, 5 plus 9, 9 plus 5 is 14. Then plus k into this column and row. So 2 minus of minus 6 to 8. What have I done? I have taken ijk determinant to find, I want to find ABC. So I am looking at the cross product of the DRs of both the lines, which is 1, 2, 3, minus 3, 2, 5. Now this will be I into 10 minus 6, which is 4, and minus j into 5 plus 9, which is 14, plus k into 2 plus 6, which is 8. So the DRs are 4, 14 and 8. That is 2, 7 and 4. So substituting for the DRs, you will get x minus 2 by 2 will be y minus 1 by 7 equal to z minus 3 by 4. So do you understand how to write the equation of a straight line which is passing through a given point and perpendicular to two lines? If it is perpendicular to two lines, it's perpendicular to this and this vector and this vector. There's cross product is also perpendicular to the two given vectors. Therefore, the given line will be parallel to the cross product of 1, 2, 3 and minus 3, 2, 5, which is given by 4, 14, 8, that is 2, 7, 4. So the equation of the line is x minus 2 by 4 equal to y minus 1 by 7 equal to z minus 3 by 4. So today we just touched upon the basics of three-dimensional geometry with respect to problem solving. Like simple problems, how to write equation of straight line, how to find DCs, how to find DRs, how to find a point on a line, how to find angle between two lines. I hope you have understood what we learned today. So this is part 1 of a series of videos which I am planning to do on three-dimensional geometry. So I hope you will find them useful. So until we meet next time, it's goodbye.